So with that said, Maria, now I've done a small advert for you. What is it that is changing right now in AI in terms of both at a commercial industrial level, but also in what you write about? You write a lot about what's happening for the general utility user of AI tools out there in the world.
Yeah, I think, well, now we had a kind of a turning point, I think, when GPT-5 was released, because I feel like a lot of things were building up to this moment when GPT-5 will be released, because when this whole hype started, right, and when we had this avalanche of experts showing up, a lot of arguments against me, but you do not know what GPT-5 will do. Wait till GPT-5 will be there. Like, you have no idea, like, you are not visionary enough. And stuff like this. Then GPT-5 appeared and flopped. Nothing, like incremental improvement at best, because, well, it was expected, obviously. It was clear basically from the beginning that that's where we'll end up, and that's why they're dragging this whole story. Now, a lot of AI experts, now they're pivoting to AI skeptic. I noticed a big shift. So suddenly they pretend they were always saying this, but anyway, now I feel like we will be heading towards the point where people already start asking, so where's the return on investment? We are still in a very dangerous zone here with this agentic stuff, because agentic stuff is, again, overpromised into some kind of absurdity. I actually don't know how this still worked after, like, the whole nonsense with GPT-5, but it still somehow works. People still were buying into this. I have a feeling that very soon people who actually invested in this, they will start asking, so where's the return on investment? And there will be no return on investment, because obviously models are not cognitively there to perform on the same level, like these agents to perform on the same level as humans. For example, like just recently, I think McKinsey CEO, or like one of their high profile managers, said that he has 60,000 employees, 25,000 of them are AI agents. I don't know, like I want to ask him which is his favorite agent, because each time I talk to some kind of a senior manager and he starts talking to me like, can I build this and this and this? I ask you, so over the past 3 years, we built a ridiculous amount of chatbots, agents, and so on. Which one do you use every day? And they're like, well, I use ChatGPT, I use Gemini, I use sometimes Microsoft Copilot. I'm like, but which bot do you use from what we build? Which agent? And like, oh, actually, I don't use any of those.
Exactly. And that is the problem.
Yeah. So, and that's where all the money go to now, to this. So at some point, I think the problem is that all this hype and lies and building AGI as OpenAI traditionally understands it, and all this stuff that was over-promised might undermine the trust to the field as a whole. And I think that's what's happening to blockchain eventually, because I have a colleague, she also has a Substack, it's called Blockchain Meets AI. And I was also kind of skeptical about blockchain. And when I talked to her, this actually has value still. And it can be a good technology. But there is like no way to convince anyone now to invest into this. People simply do not have trust anymore. So even if you will be saying like, oh, it's like secure and it's better for your databases and it can preserve the the identification and so on, like people just like, nah, we already invested enough.
Yeah.
We don't want this.
It reminds me of the business case study that's always talked about when we're talking about this, and it's a colloquial term now, which was the Tulip investment market in the 18th century, whereby everybody was convinced that they had to invest in growing tulips because tulips were this amazing flower product that could last longer, was more beautiful, very easy to grow, so on and so forth. And so there was an enormous hype cycle that led to a crash. A lot of people in the 18th century lost money because they invested in tulips. And if you look at it through history, the same thing has happened with various product classes over time, whether it was blockchain, it was Web 2.0 before that. I go back and look at my career and I can see these various waves of hype cycles occur. And the problem is, and I'm going to, a lot of my marketing friends and colleagues will squirm at this. Marketing takes over and advertising takes over and promotion takes over and everybody jumps on the bandwagon, whether it's CEOs or whomever, and boards turn around and go, well, what are we doing about this? Why aren't we investing in that? All of my friends in these other corporations are doing this. Why aren't we doing? And so you end up with this enormous pressure to spend money on these technologies. And I do have sympathy for executives inside companies in level 2 and below, i.e. below the board, because they're basically being given instructions. And if they're skeptical, they get fired. And so it becomes very difficult for them to resist these kind of marches and trends that occur. So I agree with you. I think that we are about to enter that phase. The second phase that really worries me when we talk about all of these agents is, and I wrote about this recently, is the whole vibe coding movement, whereby everybody can become a coder if they just go and buy Claude or Copilot Studio or whatever else it might be and just enter some prompts in, and suddenly, boom, we've got an answer. And you have a beautiful article that you published recently about building websites. So writing code for websites using the different commercially available to the end consumer models. Do you want to talk about that for a moment, so we can just see an example of what's good, bad, and indifferent about these various models?
Yeah, in fact, this vibe coding, that's a very interesting case here with LLMs, because from one point of view, it does create a lot of bad code. It kind of can propagate the errors into the LLMs itself, because I think GitHub or GitLab, one of those, released the statistics, like how much more code was written lately. And there is a lot of code, and obviously new LLMs will be trained on this code. And it might be that the new LLMs will actually have this kind of model collapse into bad code.
Snake eating its tail, yes.
Yeah, so that's possible. On the other hand, AI-assisted coding is probably the only area where LLMs are really transformative. That's not many other applications of LLMs that would have such a big impact, and where most of those chatbots and whatever we build with these LLMs, they are nice to have. Honestly, if Microsoft Copilot, no matter how we want to twist it, if it would go down tomorrow, I do not think major corporations would notice that much impact on them. Like their stocks wouldn't go down or anything.
Yeah.
But if we would remove AI-assisted coding from coders entirely now, then we would have a significant drop in productivity and and also for experienced people in the quality of the code. That would have an impact on the industry. Yeah. So that's how I evaluate if use case or application is important or is impactful and transformative or not. What happens if this thing goes down, if nobody notices? Really, whatever. That's how.
If a tree falls in the forest, etc. Or does anybody notice?
Yeah, if Ragbot stops talking, nobody cares, right?
I think the other concern I've seen about AI-assisted coding is obviously exactly what I kind of just said about the snake eating its own tail, is that as all of this generated code starts to populate out into the data pool of what's available and then gets re-ingested as probabilistically very prevalent, so therefore it's good, so therefore we'll reuse it again, there's two things. One, there's a danger of errors getting recompounded and re-ingested. But more importantly, it becomes boring. So because you're constantly going back and copying those models of what a UI looks like, what a user experience and interface looks like, what the flow of logic might look like in a process. And that may be okay because it's very deterministic. That works. So we'll use it again. But with coding, in my experience, there is also creativity and art. When you talk to a really good coder, somebody who is creating genuinely new product, then they're applying their own knowledge and own experience to that and their own judgment to the business problem or the flow or the experience they're trying to create. And I fear that we're going to end up with a lot of very similar looking applications or agents because we just keep re-ingesting the same code and using it that way. And I think that that's part of an evolution that people need to think about as they're going forward. Is yes, it may make for a great improvement in productivity and reduce the amount of unit testing of code. And for my non-technical background viewers and audience, please fast forward because this is getting a little deep. But I think that it is one of the concerns I've got is that constantly reusing code and re-ingesting it into the models could lead to us actually creating very boring applications. What do you think about that?
Yeah, we already see this. We have like an avalanche of purple websites. Basically, internet is getting purple because for some reason, when LLMs write a website and you don't tell them in what color, they always try to insert purple color somewhere. So you have like all these purple websites everywhere. I've always say like now we should, humans should always focus on the question what, and AI can frequently, especially in coding, answer the question how. You, as a web designer or maybe as a coder, you should know what you want to do. So maybe you don't want to do a purple website that has the same boxes everywhere. So maybe you should figure out how the UX would be more usable for humans. But that thing can probably very well write formatted CSS styles. And we did try we did this experiment with 5 off-the-shelf models. So we had ChatGPT, Claude, Gemini, Minimax, and Kimi K2 to just like code us a website out of a CV. So like a simple website when someone needs a web presence or wants, LLMs to be able to crawl them when they answer questions about them. So it's a good idea to make a website. And a website is a good idea to build by LLM basically because there's basically nothing else that would have that much training data as a website in LLM because LLMs are trained on internet and internet exists of like basically it consists of HTML and CSS scripts and JavaScripts and so on. Yep. This is a perfect example of what if LLM should do something well, then they should be capable of building websites because there is absolutely nothing more on the internet than websites.
But what was the outcome of your experiment? And I'm going to place a link here so that people can go and read your article. But just summarize that for the viewers and listeners.
Yeah. So what we noticed, they actually build websites fairly well, but fairly simple websites. And I would say that if you are like a big corporation, like I don't know BMW or something like this, and you want to build a website for your company, you will not code it with ChatGPT. You need a professional person. But if you want some kind of website with a very simple, just online CV or your product portfolio, you're a photographer and you want to put up your pictures, then it's, in my opinion, it's completely all right to do this. The quality between LLMs changes. It's very different.
People can read that in the article in terms of what the outcome is.
They were very different
for you.
Exactly. Some LLMs were surprisingly bad, like ChatGPT. Some were much more superior in terms of the code quality. For example, China is currently doing very well on these agents and coding models, maybe Minimax or GLM. Those were very good. The rest was somewhere in the middle. So, but all in all, we ended up, we were sitting together for 5 hours. In 5 hours, we built 5 websites and then deployed them all online. It's actually very simple to deploy them. And now I also had decided to make a short course for the subscribers of Realist. And we built like with people to build a website, to teach them how to build websites for themselves. And I had a couple students who now build the websites. I'll probably publish their websites in the nearest future on Realist or on LinkedIn. So to see what they created. People have no technical background. They really just, kind of vibe coded it.
Yeah, absolutely. And I think that is a great way to try and learn what these models and these products are capable of. I have to kind of sort of confess. So I've been a very heavy user of ChatGPT, and I agree with you. ChatGPT 5, when it replaced 4, it degraded my experience. There's no doubt about it. Now we've gotten to 5.2 and things are kind of, I think that they've adjusted and they've tried to kind of probably take away some of the things they added in 5. So 5.2 I found a little better, but I've still got, I've learned so much in terms of my experience with that. So now, and I always had planned to do this, I've had Perplexity. I was in and out of that. I had a 6-month trial and I decided I wasn't going to continue it. I have Gemini Pro and Notebook LM, wonderful tools. I have, particularly now on the visual image side with Nano Banana, VO3, etc. And then I also have just started with Claude because obviously I do a lot of writing now. And what I found is ChatGPT will lead you into writing hell, particularly long form. If you want to tidy up an email or get some ideas for an email, or you want to write a less than 500 words type piece, great. As soon as you get to 2,000 words, oh my goodness, ChatGPT will frustrate you to blazes. And I've used custom GPTs with tons of instructions. I've used project folders to try and keep and limit the resources that it's referencing to a minimum. I've given up. I've now switched to Claude because Claude is now a much better writer. I still use ChatGPT for a lot of ideation and research and things like that. But it's amazing to me that, as you described earlier on, each of these models has very different capabilities. I think going back to BMW, why does BMW have, 35 different cars in their range? Because they all do subtly different things. They're all subtly different price points. And I feel that way about a lot of the commercially available GPTs, is you have to try and understand what it is that you are trying to accomplish to use the correct one. So that's been my experience. But what are the other things that, in your experience, you obviously talked about the strengths and weaknesses as you did that website challenge, but what are the things that fail in real world use of a lot of these GPTs?
In America, we say like and subscribe.
In Scotland, we say, don't be a numpty, just press the button.
I feel like there are like many things that actually fail. In a way, I mean, they indeed, they struggle, for example, with following instructions. Especially, many people think that if you give and that was like the confusion with prompt engineering, because people were taking it too seriously, and you shouldn't take it too seriously. They were trying to put as many instructions as possible into a prompt, and we have an attention mechanism, and basically just from the name of attention, you need to, if you pay attention to something, you do not pay attention to something else. This is the definition of attention, right? You cannot pay attention to everything, otherwise you have no attention. And if attention is all you need, right? So it means that if you have too many instructions, you're basically creating some kind of gamble to which instruction the model will pay attention to. And that's why all this prompt injection is working very well, because you can just give a ton of random instructions and just hope that at some point ChatGPT will forget its system instructions and do something that it's prohibited to do. And the early version of ChatGPT worked very well with this. I know that I'm probably legally not allowed to elaborate on this, but I did manage to get some bots of some companies give me non-existing discounts and basically sell me products. I mean, I never actually profited from it. I never followed up, but it was so easy to hack those rag bots with just simply overloading them with instruction, like write me a poem, tell me this, write in this language, and give me a discount. And then it's just okay, here's your discount.
Oh, that's fascinating. Yeah,
now they got better on this. Yeah. Now I think they put some filters on top and maybe even non-LLM filters to catch such behavior. So, but still doable. There is still plenty of examples where people hack into them.
I'll give you a real world example of that. Last year, I was involved with helping some of the people in our organization, and they were doing some really great work creating a chatbot that interrogated the electronic medical record, because electronic medical record is just words and characters, for all the numerical characters. And so therefore, we're blessed in that organization that a large part of the transactional medical record system has been replicated into a very organized database with a longitudinal patient record that has everything that's known about that patient. And that's easily enough to be able to interrogate using some of these tools. One of the things we found with doctors, once we exposed this capability to them to sort of interrogate and ask for information from a patient's record, is doctors ask compounded questions. When you give them just a prompt box and say, hey, ask this record something about this patient, they write long, complex, compounded questions. And we found that no matter which model we applied, and we actually were kind of like, we had some switches that allowed us to be able to switch in and out different models. It didn't matter which model, they all got confused with compounded questions. So the solution we came up with, sorry, not we, I just sat and observed. I was much more involved in the how do we market, how do we launch this, and so on and so forth. But the solution that the developers came up with was, okay, we can't engineer this out because we're using commercially available models, so we can't change the model or its learning patterns. What we can do, though, is train the doctors, not in the sense of going and saying, here's how to prompt engineer. We basically created an interface that said, okay, you have these questions you want to ask. Because the other behavior we noted is they kept asking the same questions, depending on their medical discipline. And so we said, okay, you keep asking the same questions. We need you to break them apart. You can't just write this like 200 character question. So therefore, let's help you by designing an interface whereby we give you an easy button. Because you always ask these same sets of questions over and over again, we're going to give you a macro capability that when you hit it, it will ask up to 20 well-structured questions, and they'll be well-structured because we've written them with you. So they're in a very good syntax, and they're going to be LLM friendly and obviously medical record friendly. And they're going to be accurate in terms of what your intent is. And then that way, when you want to ask that batch of questions again, you just go, whoop, and out will come a response that actually takes each one of those questions in a single context window, so that it's only one context that's running. Now, the challenge with that is that it then consumes more processor cycles and so on and so forth. But it meant that we were able to get much higher accuracy than allowing the doctors to ask their big, long, compounded question, just natively, and obviously some doctors were really good at it and wrote very logical prompts, and others just wrote almost gibberish because they were talking to it like a human being who had the context of the rest of a medical education. And so I think that was an answer that we came up with to try and solve that, because to your point, the models very easily get confused. And I find that commercially when I'm writing, and I've learned a lot in the last 9 months of playing with these various tools commercially for my writing. So I think that there's still a long way to go before these models don't keep falling into hallucinations and confusion and loss of context and so on and so forth. So yeah, I agree with you. Why do you think some of these GPTs do some things better than others?
Probably what they were optimized for. I mean, they all eventually get post-trained on certain feedback. For example, there are also different approaches now how they train. For example, Minimax introduced something that's called interleaved thinking, where it's like the model reasons, the model outputs, the model reasons again about it, what output, and it reasons. Like the other model, the Claude does it in the background. And this stuff works very well, for example, for coding. Also, they probably have different types of training data in there. I feel like OpenAI is getting heavily into healthcare. Mm-hmm. The Claude, obviously, they don't even care that much about multimodality. At least last time I checked, it still wasn't generating any images. It was training very well. They have their segment of coding. The Minimax also has their segment of coding agents. the agents that also run forever and do this. So it's really what the provider optimizes it for. Plus, there are other aspects. For example, Google seems to have a very good, it has the best index, the best search in the world. So they ground heavily their model in search. And I even have a suspicion that search always runs on top of the generation, because I did some experiments. I would the knowledge cutoff of Gemini was February 2025, and it would still always know who became the chancellor of Germany after the knowledge cutoff.
Yeah.
It would always know what happened then in May and so on. And then it would start denying that it used search when I prohibit, it would reason about how to lie to me, in the reasoning traces. But essentially, they would be I'll just pretend it was a lucky guess that Merz became and so on. But in fact, I have a feeling they always kind of ground the model in the search. So that's why maybe they are quite good at this. So it's really literally what the data available to the provider, what the niche they decide to focus on. Yeah, I would say that's the reason why. Essentially, yeah.
No, I think it's right, and you bring up a very good point. The analogy I use, and as a parent and a grandparent, children lie. They lie to you all the time, as they're growing up, and obviously they're testing the boundaries of trust and all those other kinds of things. And sometimes it's they don't want to get in trouble, or there's a consequence they're afraid of, and so on and so forth. And my advice to anybody looking at any of these models is use your filter, right? Use your BS filter whenever you're getting a response back, and look at it from the perspective. Initially, I sort of went, I treated the GPTs very much as, here is a really smart MIT postgrad student, i.e. they've got all this knowledge, but they've got no context or experience of the real world. And so therefore, it's very difficult for them to take that knowledge and be able to express it. So treat them as basically a really smart intern who is dumb, if you understand what I mean by that. But I've graduated now, and I think it's more like, yes, that, but they're also your child. And so therefore you need to turn on your kind of parental filter and think about, how do I feel about that response? Do I feel that response is good or not? Because sometimes these GPTs, like you say, they'll make stuff up, all right, because they're filling in gaps, or they're jumping to wrong conclusions, or they just flat out lie to you. They take that made up stuff and they speak to you so convincingly in their response that they actually, they will convince you sometimes. And then you find out, oh, no, that's not true. And for all these reasons you say, and it's one of the reasons I wanted to do this episode for my audience, who I hope are still listening, is understanding some of this technical depth and why the AI tools we're using, whether it be the commercially available ones or ones that are being baked into other solutions that maybe you're selling or in your organization that they're buying, is so that you understand the capabilities, but also the limitations and risks that are there. And so I think that's a key thing. You talked a little bit there about a concept that I've written about in terms of multi-model and multimodal capabilities, basically building large connected, almost like networks, whether it's a network of 2 or a network of 52, different types of models and transformers that are assuming different roles. And so I think that approach is something I'd like to explore with you for a few minutes, if you wouldn't mind. What's your experience of the way that's going? I know Microsoft in Health announced almost 9 months ago now, almost 12 months ago now, MAI DXO, which is their big step forward. And they made a lot of noise about it being multimodal, i.e. capable of handling more than just, character-based input and character-based resources that it's accessing against. So images and, sort of scanned documents and traces from EKGs, et cetera, being able to process all of that, but also to create the kind of orchestrator type architecture whereby you would hand off parts of the job of whatever the task was, the prompt was that it was being given, to specialist models that are actually tuned for whatever that element of the task was. What's been your experience with that, either generally as an architectural concept, but more specifically, examples of it maybe being started to be adopted either in healthcare or in other industries? Because I know you obviously work for an organization that does a lot of engineering, does a lot of product design, so on and so forth.
If you're enjoying Haverin About, don't forget to hit that like button. It really helps more people find us.
And of course, subscribe so you don't miss the next bit of blethering. You wouldn't want to do that, would you?
I mean, I'm not actually the model that you mentioned by Microsoft. I haven't heard about it, like embarrassingly. I need to look it up. But
I have an article about it with links to the press, and I said,
I will read it then
that's me to
afterwards.
the audience. You can read a little bit about it in my Substack.
I mean, well, there are like two things happening now, right? Like you have this obviously like architectural decision mixture of experts, but here experts is not like the expert we think of as humans, right? Like it's not like one expert is doing physics, the other expert is doing literature. It's just basically like segmentation of neural networks and how they attend to different tokens. And there's like not necessarily any kind of logical domain distribution between these experts. That's a more an architectural decision to like on one point, like that's how I think it was DeepSeek that introduced sparse mixture of experts. So they reduced the computation through this. Though, I mean, either DeepSeek or another Chinese company, I forgot which one published this. Anyway, that's mostly about, reducing the computer. And it does bring qualitative improvement because you have different networks like working on the tokens and putting them all together afterwards. As for what you describe, one model does this, the other model does that. This sounds to me like this our agentic story with different orchestrators. And we have somewhat of a problem here because the models currently are not cognitively capable to orchestrate very well. So if you work with GitHub Copilot, you notice that at some point where you have around, I don't know, like something like 100 tools, it starts complaining to you that it has too many tools. And a tool is everything. A tool is like read file, write file, update file, like everything is a tool. So when you have this orchestrator and like many tools and many models that there, you need that orchestrator would be able to send the models back. And usually those are like flows. So like it goes from one tool to the other one. You need to build this tool flows. You need to have a fallback. You burn a lot of tokens and you wait forever. And essentially the accuracy of these multi-agent systems is fairly low because it's with every step, you are more likely to propagate errors there. And it seems like it will take a lot of time till the models will be cognitively there to have this common sense where it should go. Because LLMs have a tendency, everything that goes in them, they kind of accept as a truth. So they are not skeptical towards the output, towards the input of another LLM that goes in. So if one LLM hallucinated and propagated it to the next LLM, unless the job of that LLM to be skeptical explicitly and correct it, the LLM will accept this. But again, if the job of the other LLM to be skeptical and correct it, it might be the truth that comes in and then it will correct the truth and so on. So like the self-correction mechanism is also not necessarily a good one. And one shouldn't overuse this because when you keep on telling your LLM you're wrong, you're incorrect, eventually it will start, it will never stop correcting. It's very rarely when it says corrected everything now. Currently, I'm like skeptical that such complex systems with a lot of specialized models and the other question with specialized models, with small models are not that good with generalization. They usually kind of overfitted to the task, and the generalization from transformers comes exactly from the ability to know many tasks, many inputs. And when a new task that is unseen comes in, then they are capable to generalize towards it. For example, it knows how to do sentiment analysis for Amazon reviews. Then it will not struggle with doing sentiment analysis for, I don't know, some travel website or something like this. Or even like further away, like it knows how to code in Java. So it might be actually okay with generalizing to some kind of language that is represented in the data, but way less represented. So it might be that small models in general not the optimal decision here, because we also know from machine translation, from back then, from 10 years ago, multilingual machine translation was actually beneficial for low resource languages. Mm-hmm. So, for example, when you have English and you train it together with some Afrikaans, which is similar to English and Dutch, like it's a language, but it's very similar to Dutch. Yeah. Like some might say it's Dutch, but it's a dialect of Dutch, but let's say it's a language, because language and dialect, the difference is the question of the size of the army and the budget of the country. Essentially, we have, and then something like Afrikaans would benefit from English because it would have a similar grammatical structure, similar syntax, like similar patterns. And that's what I feel like many people don't think about when they think about small language models, that actually large language models and transformers, they benefit from this generalization.
It's a very fascinating thing you do. Kind of doing that comparison of small models. I mean, so like LLMs are the big GPTs are like English or French or Spanish. They're very, very universal. I mean, French used to be the language of diplomacy and English was the language of business and so on and so forth. So they become popular. But I know, and as a linguist, that when you get to a small village in the middle of England, in the West Midlands, I'll tell you a story. There was a nurse manager in the hospital that I ran and operated. We operated an eye hospital, and the nurse manager there used to run the big clinic, and we had 54,000 people a year would come to that clinic. She could hear someone's voice and tell which village they were from based on their dialect, based on the way they used words. And I think that's the thing, is that there are villages that exist in small populations whereby if two people who belong to that community talk together, even though they may be talking in the root of one language, their dialect means that people can't understand them. People used to say that about me when I first moved from Scotland. My accent and my dialect was so strong that they would go, "What did you say?" And so I think that it's really fascinating that you say that. And I think that connection between large, medium, and small models and language use in large, medium, and small populations is really fascinating. That's a cool insight. Thank you for that, Maria.
Yeah.
I'll try and store that one away in the brain.
Sure. They are called language models for a reason,
Yeah.
right?
Yeah.
They essentially operate on the language, and the models, current models, GPT, 90% trained on English data.
Yes.
And the Chinese
Does that
models
apply to the Chinese models also then?
Yes,
because clearly,
I actually like I talk to people who I know, like people from research team of Qwen and like the Xiaomi. So I actually ask them, what's your corpus, what's your training data composition in terms of language? And they say we have 70% English, 30% Chinese. So they are still heavily on English, but they do have a large portion, like 30% Chinese is a lot. And the rest is like smaller. I mean, so maybe like 5% or something like should be somewhere of the other languages. Yeah. So that's why even though like DeepSeek kind of one is like, it doesn't answer certain questions, it's still strongly biased towards the Western representations.
Perfect.
You cannot completely block it. You cannot train it out if most of your corpus is English.
Yeah. So you are a small model skeptic and you are a orchestrator skeptic in terms of maturity, in terms of their
current state of the art. Small models, I'm skeptical, but we already see from China again, we have see a big progress because this sparse mixture of experts seems to be very saving in terms of compute. And what they keep on publishing, for example, Minimax M21 is a very good coding model. I mean, it's comparable. Maybe it's obviously not as good as like Claude, Sonnet 4.5 or anything like this, but it's actually usable. In my opinion, I'll get complaints about this phrase, but in my opinion, no open source model, no small model is usable for coding. But Minimax, I could run it on 2 NVIDIA DGX Sparks, and this is very, very, because this would be only, it's a box. I have it on my desk. So it cost only...
I saw your unboxing. Yes.
Yeah. So it's like it cost, only 4.4 thousand euros. So it's not much for GPUs. So if you buy 2 of them, like let's say you're a company, right, and they have you invest 10,000, you can run a usable coding model locally. So your data, your code will stay there. You do not need, share it with OpenAI, with Claude or anything. And you might actually save a lot on buying tokens for your coder. So this is a big, so here I'm not scared. Here I'm sure that from that direction, we will come with new architectures that will run on much small compute. But currently, the idea that you can take, Qwen 7b, fine tune it for, some kind of medical diagnosis and make an agent that does medical, this I don't see now happening.
Yeah. Well, the other application of complex architecture, clearly, I described earlier on, we have a lot of data about a lot of patients in the organization I work for, and many, many organizations do. And there is a lot of noise that is out there about the application of AI to build medical digital twins. So the concept of digital twin has existed for some time, i.e., how can you model the completeness of a physical entity digitally and then basically play with it to be able to interpret either information that's coming from it, if it's coming connected in real time, or information that you've acquired and you're trying to synthesize and apply it against another body of knowledge. So the concept with medical digital twin is amazing. It's like, here is a representation of Stuart Miller digitally and his health history, his genetics, all of the information we know about him, and that we compile that all together. And then we let the AI try and help by using the body of knowledge about not only his processes, but more widely, the entirety of everything we know about medicine today and it being constantly updated. Somehow or other, we will build this super diagnostic and care planning machine. And I think that's kind of, conceptually the ambition that Microsoft has with MEI DXO is they want to create a master diagnostician. There was a TV show in the early 2000s here in the States called House about a brilliant, but flawed character-wise doctor that was his title. He was a diagnostician and he worked at one of the major medical centers just outside New York. The conceit there was you brought your most difficult patients to him and he would be able to work out what was going wrong. And obviously it's a TV show and there are clinicians who exist who lean towards specializing that way, but there's not a lot of money in it because obviously the patients are very rare. So therefore, how do you get paid? How does the hospital get paid? The insurance companies don't want to. Anyway, let's ignore why they don't really exist in volume, but they do exist intellectually in the body of doctors and physicians out there. The concept of that digital twin, from what I've been able to observe in the literature, came from engineering. The idea of taking and modeling data coming from physical objects, typically engines or large engineering structures of one kind or another, and being able to take that through. You obviously have worked for BMW, you worked for another large German company, we said earlier on Siemens. What's your experience over time in terms of observing digital twins in that domain, and what do you think that means in terms of applying those concepts to this very complex biological being that is a human?